Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome. In this topic, we are going to discuss on human development. Okay, under this topic, we are going to discuss four subtopics, which are first, physical development, second, cognitive development, third, socio-emotional development, and lastly, moral development. Okay, under physical development, we are going to look at all physical developments from prenatal until adulthood. Okay, in particular, first we are going to discuss all physical developments in prenatal stages before birth, and then during infancy and childhood, followed by physical development in adolescence, and lastly, physical development in adulthood. Okay, in the prenatal physical development, it begins with conception. So what is conception? Conception occurs when a single sperm cell from the father, from the male, merges with the female ovum or the mother's ovum, or simply known as egg, to produce a zygote. Okay, and this zygote will develop in three different phases. Okay, developments of zygote to fetus is divided into three periods, which are germinal periods from weeks 1 and week 2 to embryonic periods from weeks 3 to week 8, and lastly from fetal periods, okay, from 2 months to 9 months. Okay. Under germinal periods, weeks 1 and weeks 2, conception happen, like we discussed just now, and zygote attaches to the uterine wall. Okay, then after that, during 3 to 8 weeks, cell differentiation start to happen, okay, where cell will start to emerge into different organ. And we can start to see the different organs started to show in the embryo. And after it reaches to the fetal periods, organ functioning increases. Okay, we can start that the heart start to function, whereby the weight as well as the size of the organs also start to be noticeable. In these prenatal developments, there are other developments they are noticeable in the embryo as well as in the fetus. Okay, for example, at about 4 weeks, an embryo is about 0.2 inch or more or less or less than 1 centimeter long. Okay, the head, the eyes, and the ears begins to show. Okay, if the mother goes through a scanning, okay, they can start to see the head, the ears, as well as the eyes. The head and the necks are basically half of the length of the body. Okay, these are the two physical or most noticeable organs of the embryo. Okay, by 8 weeks, the developing embryo is about 1.6 inch or more or less 4 centimeter long, and has reached the end of its embryonic phase. Okay, it has reached the end of the embryonic phase. It has become, at this stage, a fetus. Okay, a fetal stage is a period of growth as well as perfection of the details of the organ. Okay, for example, at this stage, the heart has been beating for more or less a month. The muscles has begun to show some movement. Okay, the muscle has just begun their first exercise. At this stage as well, at about 4.5 months, okay, the fetus is just over 7 inch or about more or less 18 centimeter long. If the thumb at this stage comes closer to the mouth, the head of the fetus will turn or may turn, and the lips as well as the tongue begin their sucking motion. Okay, if the mother goes through scanning, we can see that the babies in the tummy are sucking their thumb. Okay, this is basically a natural reflex whereby the babies inside the tummy will show survival instinct. Those physical developments in prenatal stage are natural, where do not require any human interventions, okay, to go through all those processes. What are more important at this stage are for the parents, for the mother and for the father, to understand what are the risk factors that may affect the health of their baby, okay, the health of the embryo and fetus. Okay, under prenatal physical developments, they are threats. Okay, they are threats to the fetus. Okay, Okay, for example, this threat can happen due to the effects of teratogens. We are going to discuss in more detail after this, as well as preterm and low birth weight of the infants. So what is teratogen? Okay, teratogens is basically any agents that causes a birth defect. Okay, teratogens may include any chemical substance, okay, any chemical substance ingested by the mother, okay, voluntarily or involuntarily, okay, such as nicotine if the mother smokes, or alcohol if the mothers drink. Okay, besides these chemical substances, teratogen may as well caused by illnesses. Okay, for examples, rubella or German measles. Okay, the effects of teratogens depend on the timing of the exposure. Okay, when the mothers face or exposed to these chemical, for examples. Okay, for examples, heroin. Okay, babies born to the heroin users are at risk for many problems, including premature birth, low birth weight, physical defect, breathing problems, as well as worst case scenario, death. Okay, so one specific example of teratogens or substance that being focused by the researchers or developmental scientists, they look at the alcohol, because in some culture, in some contexts, consuming alcohol are considered normal in their settings. Okay, mothers who consume alcohol may cause a very specific abnormalities to their infants, okay, which are called as fetal alcohol spectrum disorder, or FASD. So what is FASD? FASD are a cluster of abnormalities and problems. Okay, cluster of abnormalities and problems that appear in babies, in infants whose their mother are consuming or were consuming alcohol during pregnancy. Okay, so if their mother consume alcohol during pregnancies, their babies may demonstrate these abnormalities. So if you look at this drawing, okay, babies who are the victims of fetal alcohol spectrum disorders may demonstrate or may inherit small head, low nasal bridge, small eye opening, short nose, thin upper lips, okay, underdeveloped jaw, smooth philtrums, okay, flat mid-face, as well as epicanthal folds, okay, their beginning of their nose. Okay, so these are some abnormalities that will be inherited by the babies whose their mother consume alcohol during pregnancy. Beside teratogens, okay, heroines and alcohol and etc., they are a risk to fetus if the fetus or if the infants are having preterm birth, okay, preterm infants. Okay, preterm infant itself is less risky, but it will be problematic or riskier if the preterm infants are having low birth weight. Okay, preterm infants, usually those who are born prior to the 37 weeks after conception, and combination with a low birth weight, okay, the infants may be at risk of developmental difficulties. Okay, so those are the risks of prenatal developments during pregnancy. Okay, those are physical developments during prenatal stage. Okay, after that, after the infant was born, so we can look at the physical developments in terms of reflexes, motor and perceptual skills, as well as the brain. Okay, especially during infancy and childhood stages. Okay, reflexes. Okay, infants as well as young babies, even though they cannot do any physical activities yet, okay, the most that we can observe during this stage is their reflexes. Okay, actually, reflexes are considered as genetically wired behaviors. Okay, why? Because all babies, all infants inherit these behaviors, even though they have not yet observed, they have not yet been trained or teach, or they have not yet learned about those those behaviors. Okay, some of these reflexes are very crucial for survival. Okay, and even some of these reflexes are considered or can be observed in human beings throughout their life. Okay, they have these reflexes until they die. Okay, some disappear in the months after birth as infants develop voluntary control. Okay, the first reflex that we can observe in infant is rooting. Okay, so what is rooting? Rooting, when we poke or touch the infant, they will turn their head. Okay, what happens when infants show rooting? Their head turns in the direction of the touch, and usually the infants will open their mouth for feeding. Okay, that is natural. Every baby does it. Okay, so what are the behaviors that provoke these kinds of rooting reflex? Okay, such as stalking of the infant's cheek. Okay, we poke or we touch their cheeks, then they will turn towards the direction of the people who poke them. Okay, the second reflex is gripping. Okay, so what is gripping? The infants grasps, okay, hold the items that they can hold on very well. Okay, almost enough to support his or her own weight. So when you put your fingers inside their palm, okay, they will grasp it. Okay, this is gripping. Okay, so what provokes this gripping? Something that is placed in the infant's hand. Okay, the third reflex is toe curling. Okay, toe curling. So when we touch, okay, if the inner sole is stroked, okay, the inner sole of the legs, okay, of the infant is stroked, the infant curl his or her toes. Okay, if the outer sole is stroked, the toes spread out. Okay, when we touch the back of the foot, okay, it will curl. Okay, if we stroke behind of the foot, then the fingers will spread. Okay, how to provoke this? Stroking of the inner or outer sole of the infant's foot. Okay, the fourth reflexes that infants show is moro, or known as well as startle as well. Okay, so what is moro or startle? The infant throws his or head back and arms and legs out. Okay, so when they hear sudden noise or movement, their head will go back, their hand and legs will go front. Okay, so that is normal reflexes for infants. And the last reflex is gallon. Okay, gallon. So what is gallon? Gallon is when the infant curves to a side that was stroked and looks like a fencer when doing so. Yeah? Say for example, if you touch their backs on their right sides, so they will curve. Okay, they will curve towards the stroke. Okay, looks like a fence. So how can we provoke this reflex? Is by stroking the infant's lower back next to their spinal cord. So these are the 5 reflexes which are genetically wired. In other words, natural for all infants, for all babies who were born. Okay, beside the reflexes, we can also observe physical developments in infancy and childhood in terms of their motor as well as perceptual skills. Motor movement here refers to the muscles or physical movement. Okay, motor and perceptual skills usually are related to each other. Within 12 months, the infants can sit upright, standing, okay, stooping, climbing, and often walking. Okay, these are the normal developments of motor skills during the first 12 months after birth. Okay, in the second year, rapid gains in running and climbing. Okay, you can see that our younger brother, our younger sisters, okay, at the age of 2 years old, they gains a lot of, or they start to show running and climbing skills. Motor skill and perceptual skills at this stage depend on each other. Okay, what they see, what they hear, okay, these also will affect how they move. Okay, especially at this stage, environmental experience play a vital role. Okay, whereby our younger children will always explore and try to climb, try to hold, try to run, try to sit, try to jump at this stage. Okay, researchers have been using a research to look at these perceptual abilities, what we call as perceptual looking. Okay, a research technique that involves giving an infant a choice of what objects to look at. Okay, if you conducted the research, okay, based on the research finding before, infants right after birth, they prefer to look at faces. Okay, to look at faces. Okay, next, okay, after, besides looking at reflexes as well as motor and perceptual skills, in physical developments, one of the most important part to discuss is the brain, okay, the developments of physical brains. Okay, at this stage, okay, infancy and childhood, we can observe that myelination continues after birth. Okay, what is myelination? The change or maturations of nerve cells in our brain, whereby a layer of myelin forms around the axons, which allow the nerve impulses to travel faster. Okay, if you remember when we discuss about the biological aspect, okay, every neurons, okay, they have their dendrites, okay, and at the end of all of their dendrites, we can see obvious developments of myelination, how these myelins wrap up all of the dendrites. So what it does, it fasten or it help in terms of the connection, the communication of neurons. Okay, so in this, when you have myelins, okay, wrap up during all of the neurons, it will make the communication between neurons become faster. And at this stage, synaptic connection increases dramatically. Okay, okay, in your textbook, you will observe that how the neurons develops even during the first 15 months after birth. Okay, right after birth, we can see clearly the neurons, the dendrites are not really connected. Okay, only few neurons, their dendrites are connected between each other. Even after 1 month, there are huge connection networks of dendrites established. Okay, and then towards 3 to until 15 months, the dendrites spread throughout of the brains. We can see that all of these dendrites are interconnected between each other. Okay, and what happens if the babies, the infants, do not use the neurons? Okay, pruning will happen. Okay, unused connection between the dendrites, then our brain will automatically cut out, okay, or what we call as prune. So pruning is basically the process of the removal of synaptic connections, which are the connection between neurons or brain cells. Okay, when we don't use it, then the brains will cut it out. Okay, changes in the brain are the result of both nature and nurture. Okay, new experience in the world. Nature means it's natural. It's basically genetically designed like that, but also in terms of nurture. When the infant learns to observe, okay, and then exposed to new experience, then the developments of synaptic of their brains also will be impacted. Okay, those are the three physical developments in infancy and childhood: reflexes, motor and perceptual skills, and the brain. Okay, next we are going to discuss on the physical developments in adolescence. Okay, in particular, during adolescence, developmental psychologists focus on the process of or the experience of puberty as well as the brain. Okay, the brain in physical developments of adolescence. First of all, puberty. So at this stage, all teenagers gone through puberty process, a period of rapid skeletal as well as sexual maturation, mainly happen during early adolescence. Okay, for female, for example, they start to experience menstrual cycle. Okay, the first menstrual cycle they experience is during during adolescence, or in other words, menarche. Okay, on males, there is no single marker that talk about the puberty process in male adolescents. However, most discussion points towards having the first experience of wet dream or nocturnal ejaculation. During adolescence, there is an obvious physical development, which is growth spurt. Okay, begins between 9 and 11 years of age, whereby adolescents at this stage started to gain a lot of rapid physical development, especially their height and their body structure. Okay, they have started to show or to develop into adult physical appearance. Okay, in terms of hormones, at this stage, okay, at the adolescent stage, adolescents, male and female, have high concentration or increase of hormones. Okay, for male, for example, they having high concentration of testosterone or androgen. For female adolescents, they have high concentration on estradiol or estrogen. Okay, in terms of the brain, okay, adolescent at this stage, we can see an obvious changes, okay, especially they first occur in the subcortical level of their limbic system, okay, the structure of our central brain that focus or regulate emotion, okay, they're in charge of memory and reward processing. So at this stage, developments of the prefrontal cortex, on the other hand, are relatively slower as compared to developments in the limbic system. Okay, what happens? So because of these structural or brain developments, adolescents may experience lacking in terms of cognitive skills for effective impulse control. In other words, they are a bit emotional and have difficulties to control their emotion, such as anger. Okay, due to the focus of development on amygdala, the system that in charge of emotion, we can see that at this age, adolescents are more interested in sensationalized news or matters. Okay, more than facts as well as other aspects. Okay, we can see that gossiping trends, lifestyle become more important for them as compared to other aspect of their life. Okay, those are the two aspects that developmental psychologists pay attention for physical developments during adolescence, which are puberty and the brain. Okay, next, physical developments in adulthood. Okay, at this stage, we at least have 3 levels of adulthood. Okay, at this stage, okay, developmental psychologists look at physical changes in early adulthood as well as physical changes in middle and late adulthood. So we have early, middle, and late adulthood. In the middle and late adulthood, there are more specific concerns of developmental psychologists where they look at theories of aging. Okay, in other words, why people age or getting older. Okay, and lastly, we are going to discuss on aging as well as the brain in middle as well as late adulthood. Okay, physical changes in early adulthood. So what happened when after adolescence when people reach the age of 20 years old and above? Okay, in early adulthood, most people experience their peak conditions. In other words, peak of physical developments in the 20s. At this age, people are at their highest level of speed and strength. However, at the same time, during this adulthood, especially at the beginning of 30 years old, people start to show or beginning to experience decline in many of those physical activities. They can no longer perform at the highest levels that they used to perform at the age of 20 to 30 years old. Okay, the downward trend in strength and speed are often noticeable in the early 30s. Okay, in the middle and late adulthood, the physical changes also happen. Okay, quite dramatically quite dramatically as well. Okay, in the middle and late adulthood, most adults started to lose some of their height. Okay, and many gain weight. Okay, for female adult, for example, this is the stage where they experience menopause, where they can no longer produce the same menstrual cycles, okay, due to the aging. Okay, menopause usually occurs in the late 40s or early 50s. Okay, effects of wear and tear also begins to show. Okay, wear and tear here means that if you use excessively your physical condition, okay, you do a lot of physical activities. When you reach 40 years old, okay, you will start to feel, okay, pain or soreness in some of your body parts, some of your physical. Okay, why? Because you have been used these organs. Okay, your physical condition is not as the same as it used to be as before. So at this stage, if people are still actively involved in outdoor activities, okay, regular physical activity, they can have a wide-ranging benefits. Okay, when people started to feel, okay, the decline in terms of their physical activities, they started to change their behavior. Okay, how all the adults navigate physical changes. Okay, developmental psychologists discuss this aspect from selective optimizations with compensation perspective. In other words, when we reach at this age, 40 to 50 years old, all the adults change their goal or match their goals with their current physical abilities and compensate, okay, to their declines. Okay, in other words, all the adults at this age, they find other ways. Okay, they find other alternatives to do the things that they enjoy. Okay, do the things that they enjoy. Take, for example, people who likes to involve in sports. Okay, at this age, they can no longer perform the same thing the same way as they used to do. So it's either for them to change sport or where can accommodate, okay, older people, or they change from playing with younger players, younger competitors with people of the same age. Or people can even change from being a player to become a coach or manager. Okay, so those are physical changes in early, middle, as well as late adulthood. But the main question is why people getting old, or in other words, why people age. Okay, there are many theories that try to explain why people age or why people getting older. Okay, one of the most famous perspectives are biological theories of aging. So in this topic, we are going to discuss three theories or biological theories of aging: cellular clock theory, free radical theory, and hormonal stress theory. Okay, the first biological theory of aging is cellular clock theory. Okay, in the nutshell, why we getting old? Because our body cells can no longer divide. Okay, the cellular clock theory views that our cell can divide a maximum of about 100 times. Okay, at this 100 times, if we look at in terms of age, our cells become less capable of dividing. The more it divides, the less its ability to divide. Okay, the more they do it, the more they can divide. Okay, the total number of cell division is roughly related to the individual age. Okay, the more we can divide, our cell can divide. Okay, the more age, okay, the older that we get. Based on the way cells divide, the upper limits of the human lifespan are about 120 years old. Okay, so basically, if we look at this theory, maximum people can live is 120 years of age. Why? Because their cell in their body can no longer divide. So they will not be able to recover anymore. So each time a cell divide, the telomeres which protecting the ends of chromosome shorten. Okay, so in this figure, if you notice that this is our chromosome, okay, at the end of our chromosomes, there is telomeres, okay, telomeres. So each time when our cells divide, this telomeres shorten, okay. So it has a limited number of times it can divide. Okay, the more it divides, the shorter it will get. So when the telomeres is no longer available, the cells can no longer divides. In other words, we can no longer recover from our injuries or from our any cell damage. So this cellular clock theory stress that why we getting old, because our cells can no longer divide. Okay, that's why we have limited time. So after a while, we will show the effects of aging in terms of physical performance as well as cognitive performance. The second theories that explain why people getting old is free radical theory. So the free radical theory of aging states that people getting old because of the unstable oxygen molecules, which known as free radical, are produced inside our cells. Okay, when we are getting old, okay, our body produce these free radicals oxygen molecule. Okay, so it's in our DNA. So these molecules, the free radicals oxygen molecules, it damages our current DNA, and this damage, okay, will also affect our cell structure, okay, our cellular structure. The damage done by these free radicals oxygen molecule will lead to a range of disorders, will make us having illnesses or sickness, okay, such as cancer and arthritis. So we getting old because our body, okay, produce oxygen molecules known as free radical. Okay, the third theory that explains why we age is hormonal stress theory. Hormonal stress theory. According to this theory, agings in the bodies of a person, okay, will create a lower resistance to stress. Okay, aging in the body's hormonal system can lower resistance to stress and increase the likelihood of disease. Okay, so when we are younger, so we are, maybe if not immune, we are a bit resistant to stress. Okay, why? Because our cells are still relatively new. Okay, we still strong at that particular time. But when we are getting older, we become less resistant. Okay, we get tired easily, we get sick easily. So when this lower resistance to stress happen, it increases the likelihood that we will get disease. Okay, as individuals getting older, stress hormones stay in our body or in our bloodstreams longer. So what happens? If these stress hormones stay in our body longer, a prolonged elevated level of stress hormone are linked to increased risk of many diseases, okay, including cardiovascular disease, cancer, and diabetes. Okay, so from this perspective, why people age or getting old? Because our body can no longer resist, okay, stress hormone. Okay, can no longer resistance to the stress. Okay, so those are the three biological theories of aging. Okay, another perspective of physical developments in adulthood is developmental psychologists also look at the brain. Okay, the process of aging as well as the brains. Okay, unlike common or public understandings that when we are getting old, our brain no longer produce brain cells. Actually, when people conducted research, they found that adults, even at the age of middle and late adulthood, can still grow new brain cells. Okay, adults can grow new brain cells throughout of life. Okay, for example, in our hippocampus as well as the olfactory bulb. Okay, our sense of smell. So research currently studying factors that might inhibit and promote neurogenesis, okay, including various medication, drug, okay, stress as well as exercise. So neurogenesis refers to the process of generating new neurons. Okay, researchers are focusing on that, and they found that even in middle and late adulthood, people are capable of producing new brain cells. Okay, some brain areas, Okay, some brain areas are admittedly shrinking more than others while people getting older. Okay, they shrink. Okay, they become smaller. For examples, the prefrontal cortex, okay, is one of the areas that shrink when we get age. Okay, the things that the part that we use to process information, new informations, okay, in our brain. Research has linked this shrinking, okay, to a decrease in working memory. Okay, so the result of this shrinking, okay, people have a smaller capacity of working memory and other cognitive activities, okay, in older adults. Okay, even though there are some parts that are shrinking, there are parts that are less vulnerable to any deficiencies or shrinking. For example, the sensory regions. Okay, research found that the sensory regions of the brain are less vulnerable to the aging process. Okay, even though we are getting older, the sensory regions of the brains are basically remain more or less the same. Okay, for example, the primary visual cortex, primary motor cortex, and somatosensory cortex, all of these parts are less vulnerable as compared to prefrontal cortex. So the reason why these areas of the brains are less vulnerable because of two factors. One, because our brains rewired themselves. Okay, they rewired themselves so that we can activate multiple places of the brain to do a cognitive process. And secondly, because the decrease of lateralizations. Later, we are going to discuss in more specifics. Okay, in nutshell, lateralization is the process of specializations of the brain. Okay, if some part of the brains specifically focus on arithmetic abilities, another part specifically focus on language abilities. Okay, so when we are getting older, this process of specializations is become lesser or decrease. Okay, so even in the late adulthood, the brain has a remarkable repair capability. In other words, this is the part that the brain rewired themselves. Okay, one of the researchers, Stanley Rappaport, compared the brains of younger and older adults when they are engaged in the same cognitive task. So the older adults' brains, okay, the brains of older adults literally rewired themselves to compensate for the losses. Okay, actually, in terms of brain structure, older adults don't stand similar advantage as younger adults. However, there are processes that happens where in terms of result and performance, older and younger adults demonstrate more or less similar performance. Why? Older adults, their brains compensate for the losses with activities or process of rewiring, okay, their brain activities. If one neuron was not up to the task, okay, for this is for all the adults' brain, neighboring neurons in their brain will pick up the process and will pick up the slack. Okay, so they will compensate for that. Okay, as brain age, they can shift responsibilities for a given task from one region to another. Okay, this is also related to the next point of discussion, which is lateralization. Okay, when we are getting older, okay, when we age, the decrease in lateralizations also help us to compensate on our cognitive limitation, okay, cognitive deficiency. Okay, the decrease in lateralization in older adults might play a compensatory role in the aging brain. Okay, in the aging brain, using both hemispheres, right and left, may improve the cognitive functioning of older adults. Okay, so what is lateralization? Like I mentioned just now, lateralization is the process of specialization. Okay, specializing the function in one hemisphere of the brain over the other. Okay, however, when people getting older, this specialization or specializing process become lesser and lesser, decrease. Researchers found that brain activity in the prefrontal cortex, okay, is lateralized less in older adults than in younger adults when they are engaging in cognitive tasks. Okay, so basically older adults use both of the hemispheres as compared to younger adults which only use one hemisphere. So younger adults activate only one hemisphere to complete a task. Okay, on the other hand, older adults can show the same level of performance but by using both hemispheres. So these are the processes. Okay, these are process that happen in our brain when we are getting old. Okay, so why some parts of our brain, especially in sensory organs, become less vulnerable as compared to others.